There's Yaskawa. You can see it. Well, maybe you can't see it, but it's way back there. Can you see it now? Hold on, can we see it now? Yaskawa back there. Boom.
Come on, you.
Nope. Landon just broke the robot. I gotta go.
Can I actually go?
Here we are at the Yaskawa booth. So here we got a simple palletizing operation, which is kind of one of the key things that we do as a company. One of our go-to simple projects for us. Any type of palletizing, even doing mixed palletizing. So if you have different size boxes that come down your line, or maybe you want this one pallet to be mixed different sizes, we can do it. So here, Yaskawa also is kind of like, I probably want to say like number 2 in the U.S. So Fanuc is definitely number 1. Yaskawa is very close, and you'll also see a lot of different manufacturers in the industry will stick to a certain brand. Like Toyota has a lot of Nachi, and a lot of places have a lot of Fanuc. That's, if you're really training on a robot, I think it should be Fanuc. That's mainly because of how many's out on the market. Here we're just doing a little bit of a sorting. It's not doing really nothing at all besides a pick and place. Let's see what we got over here. See if there's some more technology. So we got vacuum. Let's see. Yeah, I think that's really it. I really don't think this thing's got anything going on fancy-wise. It's just simple pick and place operation. I don't think they're using coders or anything like that. Okay, they are demonstrating the laser scanners right here. So I don't know if you can see, Landon, if you want to stick your arm through that hole, like you're basically simulating you sticking your hand into the cell. He showed you how the robot's moving with his hand inside the cell. So look, go through the first runway. Now we'll stop. Now we'll move slow again. Now we'll move full speed again. So you can program in things like that with your safety, and do the proper risk assessment and stuff like that. That you can have collaborative robot technologies without having an actual collaborative robot. It's not even 110% required that a traditional robot has to be fenced in. There's a ton of other safety requirements that are involved with having a non-fenced in robotic cell. So we're gonna go ahead and run over here to the collaborative versions of the Yaskawa robot. Definitely super cool. Love their teach pendant. So I'm just gonna show you quickly like what this thing looks like. You have your button for teaching your robot. Here's what the teach pendant looks like right here.
Come on, you.
Nope. Landon just broke the robot. I gotta go.
Can I actually go?
So with the teach pendant, if you don't know anything about jogging robots, a dead man switch, the way that it works, they have a different name. They call it enabling switch now because they don't feel like calling it a dead man switch is proper. But so the way a dead man switch works is right here. Right now it's obviously released, like very clearly. So as you can see, we're very clearly released on the dead man switch. If I grab this and I push as hard as I can, you've also defeated the dead man switch. So now the dead man switch is no longer active as well. You actually, whenever you hold a dead man switch, you have to hold it in the center. Too much pressing will activate it. So it's not, the dead man switch is not active. Now it's active. Now I pushed really hard. Now it's not active again. So that the dead man switch floats in the center there. And then so basically you gotta activate your servos. Pressing your dead man switch halfway. Oh. Servo power required. Okay. And notice it has your, this will come up on your screen right there when you're able to jog. Oh, we reached the limits. There we go. So right now we're just jogging around in a joint mode. You see how each individual joint is moving? Not like they're pendant. It's learning where the tools are. Joint by joint. So there's different ways of moving these robots, whether it be a joint mode or whether you're using a Cartesian mode. I'm not gonna play around with the robot too much. We've already broke it, I think. No, I'm just kidding. But then you have Cartesian mode where the robot will follow its TCP and move in like an X, Y, Z type of fashion, and all the joints will follow this TCP.